Hello everyone. Today what we're going to do is we're going to learn about the product and quotient laws of logs. We're going to start off with a little warm-up here and 3 questions, something that you guys have already done previously, so we're just going to take that up. First question is, when multiplying powers with the same base, you tend to add the exponents. So I'm just going to take a pen to do that instead. So when you have exponents with the same base, what you're going to do is basically essentially just add the exponents. So it becomes a to the power of m plus n. Similarly, when dividing powers with the same base, you will subtract the exponents, and it's the base, and it's always the first exponent minus the second exponent, regardless of if the answer becomes a negative. So it'd be m minus n. And the last question, something that we have been dealing with already, is when a power is raised to another exponent, you multiply the exponent. So here we have a power where it's raised to an exponent, where the whole thing is then raised to another exponent. So you are going to multiply the exponent. So it's m times n. Okay, and just to do a little recall of the exponent laws, things that we just finished doing right now. Power law is when a power is raised to another exponent, you multiply the exponent, something that I just showed you recently. And the product law is when multiplying powers of the same base, you are to add the exponents, so it becomes a to the power of b plus c. And when dividing powers of the same base, you subtract the exponent. So it's a to the power of b divided by a to the power of c equals a to the power of b minus c. Okay, and also to do a little recall about logarithmic functions that we just finished doing in the previous unit. Just to let you guys know, the logarithmic function is an inverse of an exponential function. A logarithmic function represents an exponent. I'm just going to show you briefly what that basically means. So if I have an exponent, if I have an exponential equation as 2 to the power of x equals to y, I can write this as a logarithmic function by writing log of base 2, so we keep the exact same base, of y equals to x. So basically the exponent here is represented by the logarithmic function. Also, to do a little recall about power law of logarithms, it essentially states that if you have an exponent of a log function, you can actually bring that exponent down, so you can multiply that exponent with the logarithmic function, so that n comes down. And just to let you guys know, the restrictions on here, a restriction on a logarithmic function is that x must be greater than 0, b must be greater than 0, and b cannot equal 1, and n is an element of all real numbers. Okay. What we're going to do now is we're going to be learning about the product law of logs as well as the quotient law of logs. I'm going to actually derive the product law of logs for you guys first before we go ahead and reuse it. I will also derive for you the quotient laws of logs as well. Okay, so the first part here says find an equivalent expression for log b times mn, where b is greater than 0, b cannot equal to 1, and m and n are greater than 0. So when I start with this, I'm just going to define a few variables here. So I'm just going to say let m equal to b to the power of x, and let n equals to b to the power of y. So those are some of the let statements that I've introduced. So some of the variables that I'm going to be introducing now. I'm going to substitute in m and n for b to the power of x and b to the power of y into this expression right here. So I have log b times mn, that is equal to now log of b to the power, base b, b to the power of x times b to the power of y. And just recalling our product law here, if we have the same base, we can add the exponents when we're multiplying two powers with the same base, So it's log of b to the power of x plus y, And also now using our power law, when we have an exponent raised and we have a logarithmic function, we can then bring that exponent down and multiply it with a logarithmic function. So here I have x plus y times log of b of b. And as we all know, there is already one of the logarithmic properties that we know, log of a base a raised to a is equal to 1. So we're just going to use that property here. So this right here becomes 1, and we're essentially left with x plus y. Okay, so right now we have log of b, dot product n equals to x plus y. I'm going to go back to my let statement. I'm going to rewrite this expression here, so these equations here, into my logarithmic function. So just writing this as an inverse of a logarithmic function, I'm going to have x equals to log of b of m, and over here I'm going to have y equals to log of b of n. Sorry, I just don't have enough room here. I'm going to write it down on the side here so you guys can actually see what I've written. So x equals to log b of m, and y is equal to log b of n. And now I'm going to take those two equations, I'm going to substitute it into my expression here. So I have log b of m plus log b of n. And I'm just going to copy this down right here. So log b n times n. So essentially what you can see here is that log of a product is actually equal to sum of their individual logs. And that is the product law of logs. I'm just going to highlight that for you. This is called the product law of logs. Now when I'm deriving the quotient law of logs, it's the same way and it's the same methodology that I've just used here. Instead of multiplying my exponents here, I am going to now divide them. So let's just go ahead and do that. So if I have log b of m divided by n, so this is a quotient of m and n, and the same criteria would follow, and the only other criteria that I'm going to add to that is that n cannot equal to 0. So b must be greater than 0, b cannot equal to 1, m must be greater than 0, and n must be greater than 0, and it cannot equal to 0. Sorry, that's already stated in here. I apologize. Okay, so let's go ahead and now derive this. So I have log b of m over n. That is going to equal to log b. I'm just going to substitute m and n as b to the power of x and b to the power of y. So it's b to the power of x divided by b to the power of y. And when we are dividing powers with the same base, I can essentially just go ahead and subtract my exponents. So I have log b of b to the power of x minus y. And according to my power rule, I can bring that exponent so that it multiplies with my logarithmic function. So I have x minus y times log b of b, and we just stated that this is equal to 1, so it's x minus y, and we all know what x minus y is. It's just equal to log b of m and log b of n. I'm just going to substitute that in right there. Just need a little bit more space here. So it's going to equal the log b of m over n is now equal to log of base m minus log of b base n. And that is basically called my quotient law of logs. Alright, perfect.